Power plants and substations are the major components of the energy system. Aside from power transformers, the main parts of such a plant include instrument transformers, the protection and control system, as well as switching elements like circuit breakers and disconnectors. For a reliable supply of electricity, the correct operation of all individual components and their seamless interaction has to be assured during the entire life cycle of the plant. Commissioning tests are performed to verify manufacturing data, identify and fix possible transportation damages, and confirm correct wiring. In refurbishment projects, the parts of the system with a shorter lifespan are renewed, while other components remain in service. The performance of the remaining apparatus has to be verified, and the proper interaction of old and new components needs to be confirmed. During a station's operational lifetime, measurements are performed as part of periodic maintenance activities, as well as for troubleshooting. The testing of individual components is based on their respective functions. Current transformers, or CTs, have to transform the primary current to a secondary current needed for control, protection, and metering systems. The secondary current must be accurate in amplitude, polarity, and phase in order to allow accurate metering and proper operation of the protection system. Protection CTs must be capable of driving high fault currents to the protection system without saturation. And vice versa, metering CTs must provide accuracy within the range of operational currents and saturate slightly above that range in order to protect the energy meters. Thus, testing of CTs normally includes verifying the ratio and phase displacement, testing the polarity, measuring the magnetization curve and knee point, measuring the winding resistance and secondary burden, and calculating the accuracy limiting factor for protection CTs, or the instrument security factor for metering CTs. It also includes the demagnetization of the CT after testing. Potential or voltage transformers, or VTs, have to transform primary voltages into levels that can be applied to control, protection, and metering systems, with sufficient accuracy and correct polarity. Thus, during the commissioning or refurbishment of a substation, testing a VT includes checking its ratio and polarity and measuring its burden. Circuit breakers, disconnectors, and other connections in the primary circuit must have good contacts in order to allow operational currents to flow with minimal losses. Contact resistance measurements are performed to ensure tight connections or to identify and eliminate corrosion. All of these substation components, breakers, CTs, and VTs, are connected to the protection and control system. The connections from the CTs and VTs and their individual cores to meters, automation units, and protection relays must be correct, as well as those running from the trip circuits to the circuit breakers. Thus, after testing the individual components, their interactions need to be verified. Injecting current in the range of fault currents into the CT's primary side will cause the protection to trip and allow the whole chain to be verified. Making a substation or power plant work is no small undertaking, and it requires all of its major components to be tested and their interaction with one another to be assured.